Welcome back to the Deep Dive. We're all about getting you up to speed on key tech topics fast without drowning you in details. Today, we're tackling Amazon's Elastic Load Balancer, ELB. I kind of think of it like the ultimate traffic cop at a super busy intersection. Directing all the user requests, the cars, making sure they go to the right places, the healthy servers, the open roads, preventing jams.
That's a perfect analogy. It
Yeah.
really is. ELB is an AWS service, and its job is basically to automatically spread out incoming network traffic. It sends it across multiple targets, think EC2 instances, containers, that kind of thing. The whole point is to seriously boost application performance, keep things available, and let them scale up smoothly. Stocks any one server getting totally swamped. It's pretty fundamental for reliable cloud setups.
Okay, that makes sense. So indispensable, you'd say.
Yeah.
But let's dig into why it's so crucial. What are the really big problems ELB solves for people building stuff in the cloud? Is it just about uptime or is there more to it?
Well, it's definitely about uptime with high availability. Your app stays online even if, say, a server fails. ELB just routes traffic away from the problem. It lets you build systems expecting failure, which is huge, but it's also about automatic scalability. ELB can handle going from just a few users to, millions without anyone flipping switches. It just scales. And performance, definitely.
Yeah.
Spreading the load keeps things fast. Plus, there are security benefits, like handling SSL TLS encryption. And don't forget cost efficiency. It works with auto scaling, so you only spin up and pay for the resources you actually need at that moment.
Right.
Think about a big online store during Black Friday. ELB keeps that site fast, keeps it taking orders, even if some servers struggle. Without it, lost sales, unhappy customers, big impact.
Yeah, that e-commerce example really brings it home.
Yeah.
Okay, so we know why it's vital. Let's get into the how. How does this cloud traffic cop actually do its job? And you mentioned types are the different kinds.
Exactly. It's not just one kind of cop. You need specialists.
Okay.
AWS gives you three main types. First, there's the application load balancer, the ALB. Think of this as your city traffic cop. It works at layer 7, dealing with HTTP and HTTPS. Smart routing,
So how?
like it can look at the request itself. Is the user going to your site.com shop or your site.com/blog? It can send them to different sets of servers based on that path. Pretty sophisticated.
Okay, got it. ALB for web traffic. What else?
Then you've got the network load balancer, NLB. This is more like your highway patrol car. Super fast, low latency. It operates at layer 4 TCP, UDP traffic.
Yep.
Think online gaming, video streaming, things needing raw speed. It can handle millions of requests per second. Seriously high performance.
Wow, okay. Highway speed. And the third?
The third one is the gateway load balancer, GWLB. This one's different. It's like a security checkpoint at layer 3. Its main job is to route traffic through other virtual appliances, first like third-party firewalls or intrusion detection systems for inspection, before the traffic hits your actual application service.
Ah, so it integrates security tools right into the traffic flow. Interesting.
Exactly. Security inspection at scale.
So different load balancers for different needs, web apps, high speed, security, makes sense. What about the actual parts? What components make these things tick?
Good question. Under the hood, there are a few core pieces working together. First, obviously, the load balancer itself, that's the entry point, receives all the incoming traffic. Then you have target groups. These are basically just pools of your resources, like your EC2 instances, that will actually handle the requests.
Okay, groups of servers.
Right. And crucially, ELB constantly runs health checks on the instances in those target groups, pinging them, basically, to make sure they're healthy and ready to receive traffic. If one fails a health check, ELB stops sending traffic to it.
Smart. Avoid sending users to a dead end.
Precisely. And finally, you have listeners. These are the rules you set up on the load balancer. They tell it, okay, if traffic comes in on this port using this protocol, send it to that target group. So like a listener for HTTPS traffic on port 443, routing to your main web server target group.
Okay, so load balancer gets the traffic, listeners decide where it goes based on rules, target groups are the destinations, and health checks make sure those destinations are working.
You got it. You can maybe think of it like a busy restaurant. The host is the load balancer, greeting guests, traffic. The listeners are like the reservation book or seating rules. Party 4 for dinner goes here.
Mm-hmm.
The tables are your target groups. And the staff checking if a table is clean and ready. That's the health checks.
That's a great analogy, actually. It really clears it up. How does all this fit into the bigger AWS picture? Does ELB work well with other services?
Oh, absolutely. It's designed for integration. It works seamlessly with auto-scaling. So if traffic spikes, ELB tells autoscaling, hey, we need more instances, and they get added automatically to the target group. Traffic drops, instances get removed, super efficient.
So it dynamically adjusts the tables in your restaurant analogy.
Exactly. And it integrates tightly with CloudWatch for monitoring. You get all sorts of metrics, request counts, latency, error rates, so you know exactly how things are performing. And it all runs securely inside your VPC, your virtual private cloud, giving you network isolation. Maybe think of ELB as the conductor of an orchestra. It directs the music, the traffic, to the right instruments, the EC2 instances. It adjusts the tempo using auto-scaling and keeps an eye on the overall performance with CloudWatch.
Conductor, traffic cop, restaurant host. It wears many hats.
Yeah.
So, to wrap up, ELB is this incredibly versatile service. It distributes traffic, yes, but it also enables high availability, massive scalability, better performance security. It's really a cornerstone for building reliable applications in the cloud and giving users that smooth experience they expect.
Absolutely. And maybe something to think about for our listeners, given how ELB lets applications dynamically react to demand, scale instantly, and heal themselves by routing around failures. What fundamental changes has this kind of technology forced on how we even design web applications today? It's kind of transformed everything, hasn't it?